For the other 90% living in the northern hemisphere, including most of Asia, all of Europe and all of Central and North America, it's time for winter. Temperatures drop, snow falls from the sky, and a guy in a red suit breaks into homes all over the globe, and we're all weirdly okay with this? But even though most of us associate winter with cold, the Earth is actually at its closest to the sun during late December and early January. So how's that possible? Well, in case you didn't know, the Earth's orbit is not perfectly spherical, it has a slight oval shape, which means that there are points in the Earth's orbit at which it is closer or farther away from the Sun. The most distant point is known as aphelion and occurs around the 4th of July. The closest point is known as perihelion and occurs around the 3rd of January. So, while that makes a lot of sense for the southern hemisphere, it doesn't make much sense for the other half of the globe. That is, until you account for the 23.4 degree tilt of the Earth, which is what gives us seasons to begin with, also known as axial tilt or obliquity. And if we look at the Sun-Earth system from afar, we find that the Earth's axis maintains the same orientation, regardless of its position in its orbit around the Sun. And that's the key to the paradox. When the Earth is closing in on the Sun during December, the northern hemisphere is turned away from the Sun, giving us a cooler climate even though the Earth is now at its closest to the Sun. Meanwhile, the southern hemisphere is directed towards the Sun and thus gets a warmer climate. When the Earth is moving away from the Sun again, the opposite occurs. In summary, the tilt of our planet has a much greater significance compared to the variations in distance to the Sun. Rough estimates show that around 28,000 cubic kilometers of snow falls down on the Earth every single year. It's more or less impossible to imagine what that number really means, but this is what only 1 cubic kilometer looks like compared to the city of New York. 28,000 cubic kilometers of snow also contains roughly 1 septillion snowflakes. That's a 1 with 24 zeros. And as the saying goes, no two snowflakes are alike. But is that really true? This adage begins with a man known as Wilson Bentley. In 1885, Bentley became one of the first photographers to capture an image of a single isolated snowflake, and for the rest of his life he was obsessed with snowflakes, even gaining the nickname the Snowflake Man and taking over 5,000 photos before his death in 1931. He caught the snowflakes on a piece of black velvet, which allowed him to capture an image before the snowflakes melted or sublimated. And even with his limited technology at the time, he was so good at this that hardly anybody bothered to take photographs of snowflakes for the next century or so. In 1925, he wrote, "Every crystal was a masterpiece of design, and no one design was ever repeated. When a snowflake melted, that design was forever lost." The thing is, two snowflakes can definitely look alike if they happen to be exposed to the exact same conditions. These conditions include humidity, temperature, wind speeds, and so on. This claim can also be demonstrated in a controlled environment like a lab, for example. Shown here in a video by snowcrystals.com, in which a pair of snowflakes grows to look very much alike. Of course, nature is not a controlled environment, and thus two of the same is a very unlikely occurrence. However, in 1988, scientist Nancy Knight did actually find 2 tiny ice crystals in a snowstorm that looked quite similar. So maybe a more accurate saying would be something like, no two snowflakes are identical. According to Guinness World Records, the largest snowflake ever recorded measured in at a staggering 38 centimeters. Though the truthfulness of this record is questionable at best, as this supposedly happened back in 1887, which means there's no corroborating evidence to support this claim. And it is a quite fantastical claim to make, given that most reports with more substantial evidence usually range between 5 and 12 centimeters. I mean, can you imagine seeing half-a-meter wide snowflakes just sailing down from the sky? It would be a really bizarre sight. And speaking of bizarre, the largest hailstone ever found measured in at roughly 20 centimeters, weighing almost 1 kilo. It would be like bowling balls falling from the sky. If you look at a close-up picture of a snowflake, it will appear translucent, just like any other piece of ice. Then why is snow white? Shouldn't it just be a massive pile of translucent ice? Well, when light enters a material, some colors are absorbed and others are reflected away. The reflected color or colors determine what color we perceive that material to have. In a translucent material like ice, light instead passes through the material, which means that no color is reflected nor absorbed. However, it's not completely transparent like a sheet of glass, so the light doesn't always go through in a straight line. Instead, sometimes the light enters the material from one direction, bounces around a bit, and then exits the material in a new random direction. Now, if you take a bunch of tiny pieces of ice and pack them close together, just like snow, the light just keeps bouncing around between the snowflakes. Eventually, the bouncing light will find a way to escape the pile of snow and reflect back into the eyes of any potential observers. And because this happens to every frequency in the visible spectrum, the combined color of all colors is white. The same thing happens with ice cubes. One ice cube is translucent, but if you put a bunch of them together, they obtain a collective white shade. Have you ever noticed that when it's snowing outside, ambient noise seems to dampen and everything becomes a lot more quiet and muted? The reason for this is that, like many other porous materials, fresh snow is very good at absorbing sound. The pockets of trapped air in between the snowflakes actually weaken the vibrations and converts the sound into small amounts of heat. That's one of the reasons it can be so difficult to find someone lost in an avalanche. Just a couple of meters of snow can be enough to make it incredibly difficult for sound to reach the surface. While most people use the words blizzard and snowstorm synonymously, there's actually a few distinctions between the two. A blizzard is typically characterized by strong winds of at least 56 km per hour, has to last at least 3 hours, and visibility must be reduced to only 400 meters. Anything that does not meet these criteria is classified as a snowstorm. The deadliest blizzard on record is the 1972 blizzard in Iran. Some places received as much as 8 meters of snow in the course of a week, and around 4,000 people lost their lives. The blizzard was so devastating that entire villages were completely buried in snow. An interesting survival tactic used by some animals is to change the color of their fur to white during the winter. One example is the Arctic fox. It's a rather small species of fox native to the Arctic regions of the Northern Hemisphere, with thick brown fur during the summer and white fur during the winter to blend in with the snow-covered landscape. The fur of the Arctic fox provides the best insulation of any mammal, and it can survive in temperatures as low as minus 70 degrees Celsius. Another example is the bird rock ptarmigan, which has brown feathers during the summer and white during the winter. When we look at a flat map of the world, it usually looks like this. And it's easy to forget that Russia and the US are actually right next to each other. In fact, in the middle of the Bering Strait in between Alaska and Siberia lies 2 islands. The one on the right belongs to the United States and is known as Little Diomede, and the one on the left belongs to Russia and is known as Big Diomede. During the winter, an ice bridge usually spans the distance between these 2 islands, and thus it's possible, although illegal, to walk back and forth between the 2 nations. The coldest temperature ever recorded at ground level on Earth was at the Soviet Vostok station in Antarctica in 1983. Temperatures dropped to a staggering minus 89.2 degrees Celsius. The Vostok station is by far the coldest place on Earth, with an average summer temperature of minus 32 degrees. In the winter, the average temperature drops to about minus 68 degrees. The highest temperature ever recorded at the station was minus 14 degrees. For many animals and insects, the winter is one of the more challenging of the 4 seasons. Not only does food become significantly more scarce, but there's a constant struggle to stay warm in the bitter cold. One of the more fascinating strategies for survival is not by fighting the cold, but rather to surrender and give in. It's known as freeze tolerance, and it allows some insects and animals to survive the winter by essentially freezing. The wood frog can be found in many parts of Canada, and during the summer it just frogs around and does whatever a normal frog would do. But during the winter, something remarkable happens. Ice begins to penetrate the body of the frog, creating large flat ice crystals between layers of skin and muscle, encasing all the internal organs. The blood stops circulating and there's no heartbeat, breathing, or any other natural signs of life. By all common sense, the frog appears to be dead. But it's more accurately in a state of suspended animation, because when the climate warms up again, the frog returns to his normal froggy life.